Alright guys, welcome back to the solution for this really amazing challenge over here. The first video was 1 hour long and I guess no one ain't time for this one. So I have prepared this video over here, which has been cut down to the essential pieces over here. I mean, we are going through this now a little bit faster, but we have already extensively reverse engineered the important part. Therefore, in case if this is now too fast and furious, then simply just drop me a message and I will provide you the other video, which is way more longer. I do not want to re-upload it over here because then people can get confused why we are having it twice in here. Alrighty, so we want to add a quattro shot because in case if we can add 4-player shots, then we are also able to add 8-player shots, for example. Alrighty? Okay, so let's see. Our player shot, or this double shot, is being created in line 138. Let's see. Line 138. Do not rely on these line numbers, always double check it, please. Yes, but this looks good. Okay, so the visual comment would be this one over here, so you can easily recognize this, but this is not valid Smiley syntax. Therefore, I'm now using these comments, which are the original Smiley comments. So, create a new player shot. Okay, let's do it begin. And maybe let's add a few more that we can recognize this from existing code. Okay, so here is a new player shot. This is line 138. Here starts the other line and we can see this one over here was 1 player shot. Okay. Perfect. And then we also comment out the other player shot, which is this one over here. Okay, and this one ends over here after invoke static. Yes. Okay, so that's good. I guess you know what? And let's do this one last time. Maybe it's not the last time, but I guess it's easier to follow if we are having it in this way. And if we try to build this application back again and still have these comments in there, then we will get a smiley error and can easily fix it afterwards. Alrighty, okay. So now we copy paste this one and we insert it in between. So let's say create our own new player shot. Create our own new player shot and alright, so now we are having 3 player shots, but they are not visible. Why? We will find this out on the graphic tablet. Okay, back on the graphic tablet, let's see. We've got our spaceship, and this one over here. And this has now a double shot. If we pick up a red coin, remember this one is it's the original version, therefore our patch regarding to the blocking fire rate and also the double shot has not been adjusted yet. So if you want to test if we have a triple, octa, penta shot, we need to pick up a red coin first. Of course, you can already patch it, but in this video or in this solution for now, I would like to go with the clean version, that we do not mess up something else. Okay? Alrighty. So if we pick up our red coin, then we have our double shot. Okay. The first double shot, this one over here, this is our player shot 1. And this one over here, barely on screen, this is our second player shot. If we draw our imaginary line, that's the X position. Yes, that's X. So X is this one over here, left and right. And then we can see here we are having sub V11. We know V11 is -15. And here we are subtracting -15 from the X position, which means this one over here is our player shot -15. And here we can see we've got add V11, which means we've got +15, which means this is our +15 right now. Okay, where's our third player shot? This one over here. This one is at sub V11, so also at -15, which means it gets drawn over this one over here. This is why we are having 3 player shots, but only 2 are visible. So therefore we have to adjust the offset, which is in V11 right now. So V11 is holding the value -15.0. We can see this one is a floating point number. And now we need to adjust this value. So there are several different approaches. The first one we are going to do is we try to find another floating point number, put it into a register, or maybe reusing the register if it's not going to be modified in our function, and then we replace it over here. Which means if we find a floating point number, for example, minus 30, then, let's clean this up. Okay, so let's say this one over here is not V11. Let's say we are creating a new register V16, and this one holds now the floating point number minus 30. So therefore our first player shot at minus 15 will be drawn over here, and now our third player shot will be drawn over here at minus 30. This is just an example, all right? We have to rely on the floating point numbers right now that are in our function. Also, maybe a good point over here, we can only use register or floating point numbers in our function. So within our function over here. The function, let's see. So the function is process. Okay, so we can only use these values which has been defined in the process function. Because, for example, if you're using a register over here, or maybe over here, or somewhere else, then this is not available or might have been overwritten in our method already. Okay, so therefore, if you're looking for values, please only look in the method process. Okay. And yeah, I would suggest this is what we're going to do right now. So our first attempt is reusing a floating point number. The second attempt is creating our own floating point number. And the third attempt is, we will find this out. But the third attempt, I will promise this to you, is it's the most amazing part, because there we have absolutely no limitations. Alrighty? Okay, so let's see. Okay, so we go back to the beginning of this method, and let's hope that we've got a floating point number in here. In process, perfect, V12. This one over here is the floating point number 25, and it's stored within the register V12. So now we have to check if V12 will be overwritten in our method, because if we reach our code, then it might have been stored or used another value. So therefore, let's see. We are searching for V12. And this one over here, I mean, we also have to check if we are still in the method, but we are just a few hundred lines above. So therefore, I'm pretty sure we are in the method, in the process method. So let's see. Nevertheless, we are just comparing V12, so it's not being touched. And here we are just multiplicating V12. Okay, perfect. So this means V12, there's no other V12? Yes. Within the whole, nice. Within the whole code over here, we only got V12 used 2 times, and none of them is touching the register. So we're just using it, but not overriding it. Which means that's now, it's super amazing, because we can go back to our line 138, which is at line number 792. So we can be sure that V12 is available over here. So let's see. Yes, this is create our own new player shot begin. Absolutely fantastic comment. So, okay, what we are doing right now is we are using V12 over here, and that's it. This will end up in having a triple shot. I mean, we are not having a quadro shot right now, but let's see if this even works out. If it does, then we can also adjust it for the left side. So what we have done right now is we have created 3 player shots. One is minus 15, one is minus 25, and we are having a single player shot on the right of our spaceship, which is plus 15. All right? Okay, so yeah, I have to remove the comments, otherwise we will get an error, I guess. And to recognize that these are our comments, then we can make it in this way. Okay, so I guess all comments has been replaced. Looks good. Now I'm going to build this application, prepare the smartphone, and then I will see you in a few moments. Okay guys, here we are back again. I'm super excited. Let's see if this works out. So we are installing our new version. Okay, and then we are starting our version. Okay, and now we play our new version. So let's see. Okay, we've got one player shot, which might be a little bit disappointing right now, but we haven't patched our application to start with a double shot, and therefore we have to wait until a red coin appears to verify if our patch is successful. And there we have it, we've got a good RNG. Let's see, 3, 2, 1, Perfect, nice. Yes, we can see we are having a triple shot right now, and it's also working. Aliens got hit by this shot. Oh, once again, we've got really good RNG. Yes, so yeah, it works definitely. Okay, perfect, nice. So let's also adjust the other one. And let me close this real quick. Okay, so let's add one more shot that we are having a quattro shot, and also apply our patches that we are having a non-blocking fire rate and starting with our quattro shot. Alrighty? Okay, let's do this real quick. So what we need to do is we need to copy this one over here. This is the right side of our player, because we are having add, and we need to add V12. That's it. Now we're having a quattro shot. I hope quattro is 4. Yes, yes. Okay, good. So now we're having a quattro shot, but yeah, we need to get rid of our fire rate. The fire rate is this one over here. So here we are putting this 25 into V0. And here's our time to shoot. So we are putting V0 back into this time to shoot, which perfectly aligns with this one over here. Not this one. This one. So we can set this to 0, then we are not having this blocked fire rate. Okay, let's do this. Okay, no fire rate, but we are still lacking the quattro shot at the beginning, which means if we go back into our code, we are not having this entity regarding to our double shot. Therefore, we need to get rid of this one also. It's within line 137. I mean, I'm using this line numbers quite often right now, even if I told you you shouldn't rely on this, but they are okay to get an overview if you are on the correct line number. Alrighty? So let's see. 137. Okay. So double shot, yes. Move result, and then equals 0. Okay, then we jump to this condition. I guess the easiest patch is if we simply remove this if statement over here. Yes, I mean, we are storing the result right now in V0, but we are not using it, which means it looks like the following. Which means if we are allowed to shoot, which we are because we have already adjusted this one over here, then we are having now our double shot, or in our case right now, it's, let's do it in this way, it's in quattro shot. So now we are having it this way. Alrighty? Okay, so yes, let's clear the screen. Yes, I guess this looks good. So let's build this application back again and see if it works. So I will see you in a few moments. Okay guys, let's see. I have zip-aligned, signed this application. We have it installed. We have patched our quattro shot, non-blocking fire rate, and that we are starting with this shot. So this would be now a really amazing application if it works. Let's see. Space Pang, level 2, and let's see. Fingers crossed. 3, 2, 1. Nice. All right. So in the virtual machine, this might lag a little bit right now. Okay, so I guess I also have to turn the sound down. Yes. Okay. So now we can see perfect. This works, and this game is now a little bit more playable in my opinion. So it makes it a little bit more fun. Yeah, we can see it's lagging a little bit, but we've got a lot of objects right now on the screen. Okay, nice. So this is how we can reuse an existing register. Cool. But what if we are not that lucky and having a floating point number at the beginning like this one over here? This one. So how can we create our own floating point numbers? And this is something we are going to figure out right now. So we are creating a new register, putting in our own floating point numbers, and then we can adjust this offset a little bit far away. So for example, to make it an offset of 40. Okay, so let's do this. Okay, so to create our own floating point numbers, this process is way more complex than you might think about. So it's interesting how your processor is storing those floating point numbers, but I guess we do not have to dive too deep into this, because in the last video I did spend 20 minutes explaining the whole process behind this, but you can easily look this up online. So for example, this site is pretty amazing. Float to hex. This one, hschmidt.net. And here we can now see, okay, we've got a signed bit, we've got an exponent and a mantissa. So if you're more interested in the details behind this, what this exponent mantissa means, then I guess there's a lot of good material out there where people can explain this way better than I do right now. Okay, so for us right now, it means we are only having to insert this hexadecimal representation to get the floating point number, or we can do it vice versa. So for example, if you want to have 25.0, then we hit enter, and we can see 25.0 is represented in this way. So we've got the exponent 2 square 4, we've got this as mantissa, as already mentioned, feel free to look this up, and then we've got this hexadecimal representation. And let's compare this value with the one we've got over here. Yes, okay, so we can see they are identical. And yeah, this is how we can create our own floating point numbers. Okay, in case if you do not want to use websites to create a lot of numbers, because let's say you want to create 1000 and you do not want to enter them all the time over there, then there's also a good Stack Overflow entry regarding to this one. How we can do this in Python. So we simply search for float to hex in Python and then this Stack Overflow entry over here. Okay, here we can see we've got a solution for 32-bit values and 64-bit values. I guess within Smally, I mean we are mostly dealing with 32-bit values, but we can also figure this out regarding to the instruction. For example, here we can see we've got const /high16, which means we are using only 16 bits. So therefore the 32-bit approach should work over here. But if we're having a 64-bit value, then we need to use the other approach, this one over here. All right. Okay, so we can use it in the following way. Let's open a new IPython shell. Okay, and then let's see. Maybe let's close this. So we paste it in and we can see that's a function definition, float to hex. We are providing a floating point number and we get back the hex representation. Okay, so here we can see we are using struct unpack, and therefore we have to import struct first. Okay, and now we can see we are packing this floating point number and then we are unpacking it. And these are, let's see, what's the official term for this one? A format string. Yes, so these are format strings, and I guess, yeah, we can see this over here. So this is just the little endian format. And yeah, we are unpacking, or we are packing this floating point number, and then we are unpacking it again to get the represented value. All right? Okay, so when we have this method over here, we can use it, a float to hex, and we can use 20.50. Nice. This is also exactly the same value. So these are two methods you can use to create your own floating point numbers. Alrighty. In case if you want to have a detailed explanation on this one, then I can also provide an external video, a bonus video regarding to floating point numbers. But this took me alone 20 or 30 minutes to explain it because, yeah, maybe my explanation is also a little bit confusing. So therefore I skipped it out over here to save some time. Alrighty. Let's go back. So let's say we are not that lucky. Let's keep this in foreground. And we are not having this 25. So let's create a new register. Okay. And now high16, v13, and let's see. Maybe, we can also use a const value. So 32-bit. Then we can be sure that we are matching the representation of these bits. Okay, so let's say we want to have a float to hex 30 right now, 30.0. Yes, so this should work. Okay, we use this one over here. We can also make our own comment that this one here is 30 in floating point numbers. Alrighty, looks good for me. So therefore, now let's add an additional shot with this floating point number. So we go back, line 138. Okay, so now we are creating this once again. Ooh, these line numbers, I would remove this because, yeah, that's not good. Okay, So I would remove those line numbers. Was a mistake by me, but it doesn't affect this application at all as we have seen it before. So now we are creating a new one, another one. Okay. And now instead of v12, we are using our newly created register, 13. We are within the sub float. So now maybe let's draw this real quick. Okay, so here we are back on the graphic tablet. Let's see. We've got our spaceship over here. Okay, and this is the imaginary X position line. Okay, and the first one, and this is regarding to v11 and sub, which means this one was the first shot, minus 50. This is the original shot. And then we have added this one over here. And this is now v12, which was, I guess, minus 25, if I remember correctly. So v11 was minus 15. Okay, now we are having a shot at minus 25. And now we did create another shot, and this one over here. And this one is v13, which is our newly own generated floating point number. Yes, it is. So this one is at minus 30. So it's a little bit closer to this one. And it is at minus 30. All right, now we are having 3 shots on the left, and we are having this one plus 15. Whoops. Plus 15, and also this one plus 25. All right. So this is a way how we can easily extend these player shots, but it has a little bit of a downside because every time we are creating a new one and we need to use or reuse our values, we have to maybe create new registers like this one over here. Therefore, I would like to provide you an, let's call it a little bit a smarter approach. But first, let's finish this over here. So, okay, so here we are back. This one over here, create another one. And this is our third player shot, which is holding the minus 30 in there. Okay, let's copy paste this because we have now 3 on the left and 2 on the right. So we also need to have this for the add part, that we are also creating the third player shot on the right of our spaceship. So let's copy this one over here. And I mean, it doesn't really matter where we put this into. We can put it in between over here or at the end over here. It doesn't really matter. I put it in between. Okay, so now we've got the sub, we need to replace it with add, which means we are now at the offset plus 30. Alrighty? Okay, so let's build back this application and see if it works, and then we have a look into our final solution, which is, in my opinion, the most smartest one. Okay, so here we are back. I have signed this application, so let's see. Okay, and let's start it. So now we should have 3 shots on the left and 3 shots on the right. So let's see, level 5 in 3, 2, 1, go. Yes, so, okay, we are having 3 shots, but they are not that visible. I mean, we can see it at the end. Yes, okay. So the offset, we are just having an offset from minus 25 to minus 30. So only an offset of 5. So I guess a better option is if we change this value over here, instead of 30 to, for example, 40. Yes, but then we also have to do it. So let's see, IPython 3. Import bin ASCII, struct. Okay, and float to hex, and we want to have 40. Then it's a little bit more visible. All right, so this is how we can play around with floating point numbers, creating our own registers and using them to create new objects in this application. Freaking awesome, right? In case if you have solved it in any way regarding to this point, no matter how, then congratulations, you definitely deserve your blue belt afterwards. In case if not, you can still try to figure it out on your own. And now we are going to have a look into a more smarter solution, because creating these amount of registers might be a little bit confusing and annoying. So therefore I will clean this up. We start with a completely fresh application and then I show you a different approach. Alrighty? let's go. Okay, so let's have a look into another solution, which is in my opinion the most amazing one. And this is based on reusing Smiley instructions to adjust our offset. Sounds absolutely complex, but I guess it isn't that complex if we have figured it out once. So let's see. We've got our spaceship over here, this one. And here we have our double shot. So this one is now a clean version. This is the original version once again. Because, yeah, explaining this within a version we have already patched, that's a huge mess. Alright, so this is our first shot, minus 15. And this one over here is our second shot, plus 15. Okay, so we are already adjusting the offset regarding to those two shots in this line. And this one over here is subtracting minus 15. And this one over here is adding 15 to this register. So another solution would be the following. We reuse this part over here. So this means we are copying it and inserting it over here. And this means we are having an offset of minus 15 because we have simply just copied it. But now we are also reusing this instruction. So we are also copy pasting this instruction to have it twice in there. So over here we are also doing our sub, minus, float, and so on. This means instead of subtracting minus 15, we are now extracting minus 15, minus 15. So we are extracting minus 30 at all, which means we are now having our newly created player shot at minus 30. So it still might be a little bit confusing, but I guess if we are doing it right now and then reversing it once again, it might be a little bit more clear. All right? This is the approach we're going to do right now. And after performing this, we will have a look into this and discuss it once again. Okay, so let's switch back and then let's go. Okay, so let's copy this one over here. This is one player shot. And let's put it in here. Oops, sorry. New player shot, begin, end. Okay, so now we're having here our third player shot, but it overlays with the other one. But now we are using this instruction twice. And that's it. What happens right now is the following. And let's get back on the graphic tablet. Okay, so let's discuss this part over here, only this part right now. So we've got our spaceship, okay. And here we are creating, or we are getting the entity world into V0. All right, we have discussed this in the past. Then we are fetching the position X and putting it into V1. So V1 is holding position.x. Okay. And now we are subtracting V1, or sorry, we are subtracting V11 from V1. So V1 at this line, we are now at this line, is now V1 minus 15, because V11 is holding the value 15. All right, and this is also what we can see in the JDX GUI output. So maybe let's go back to this one real quick. Okay, there we have it. We are within create player shot, this world, and we are now using, or we are subtracting minus 15 from position X. All right. So back to this one over here. Now V1 would create this player shot here at minus 15. But now there's the clue. We are using the sub command once again, which means we are having it once again in our code, which means V1 is now once again V1 minus 15. So this math, I guess, is not that complicated. If we are subtracting V1 minus 15 and then doing it once again, we are in total subtracting 30 from V1, which means we are creating a player shot at minus 30 right now. And this means we can do this how often we want. For example, we can copy paste this once again, and within the next copy paste, player shot over here, we are adding another line subfloat, which means we would subtract another 15 from our player shot, which in total is 15 plus 15 plus 15 is 45, so at minus 45. And of course, this also works for the add part. So we can now adjust our shots within a step of 15 by simply just reusing this sub command once again. Amazing, right? So this is, I guess, the most easiest way to spread out our player shot without creating a lot of registers. And that's also pretty smart because we are using existing instruction to perform this. So let's do this over here. If this is now a little bit too fast, I mean, this part alone has been 30 or 40 minutes within the last video, but I guess that's way too long that you want to watch this. If this is unclear, absolutely no problem. Drop me a message. We can also discuss this together and figure out if there are certain things unclear. So that's absolutely no problem. But I do not want to spend another hour on this one if this is now crystal clear to you right now. Alrighty? Okay, perfect. So let's do this over here. Okay, this will get a little bit messy, I guess, but let's see if we can handle this. Okay, so now we've got this one over here and we copy paste it in here once again. And what we are doing right now is we are subtracting another 15, another one from our player shot. So now we've got minus 15, minus 30, minus 45, and I guess we can also do another one. Let's see. Okay. I mean, in case if we are inserting it once more, then we are just increasing the offset. So it's not like that we are adding these much player shots right now. This is just regarding to the offset. This is like we want minus 15 all the time. All right? I mean, regarding to math, this is simply just, yeah, minus 15, minus 30, minus 45, and so on. At the end, this one holds the end result, all of the subtraction values. Okay, let's clean this up a little bit. Okay, so here we are at 3, so therefore we subtract 4 over here. Okay, so now we've got the left side. Let's do it also for the right side, which means we are copy pasting this one over here. And once again, we do it this clean. Okay. All right. And this time, instead of subtracting, we are adding this. So we are simply just adding another 15 to our value. All right. Then we copy paste this. And once again, another one. And once again, another one. Okay, as already mentioned, this is the original version, so we have to pick up a coin first. But if we are performing such, or let's say more complex patching, then it's a good idea to just focus on one single patch instead of applying all. I will apply all afterwards and see how this game looks like, because I guess it's a lot of fun afterwards. All right, but now let's simply stick to this one and see if this works out. Then we can adjust our other patches regarding to the blocking fire rate and also that we start with this shot because we have to pick up a red coin first. So I will build this application and see you in a few moments. Okay, so here we are back again. I'm super excited to see how this works out. Let's install our new version. Success. We did not have any build errors. That's good. And now let's see. Level 5. Yes, single player shot. We have to wait until a red coin appears. So I create a little bit of space while keep dying. And then we have to wait. Okay guys, there we have it. Let's see. We pick up the coin and there we go. All right, it's a little bit laggy, but it works. So yes, you can see it works perfectly, which is super amazing right now. So now I'm going to add also our other patches, and I will introduce a little bit of more shots right now, because adding some new shots, I mean, it's just a matter of seconds, right? Absolutely. So I will see you in a few moments. Okay, so here we are back. I have added a little bit of more shots. I'm not sure if it's now synchronous left and right, but we will find this out in a moment. A non-blocking fire rate, and that we start with these amount of shots. So let's install our new version. Okay. And let's start it. Let's see if this works. So level 5, 3, 2, 1. Yes! So you can see you can extend it as much as you like. I guess the only limit to this one are those limits, or these limits of your smartphone right now. So it's a little bit laggy on the VM. On the smartphone it looks pretty good. And also, let's verify, picking up a red coin, yeah, doesn't affect us all. Okay, so this is, in my opinion, it's a very, very nice solution for this challenge over here. And yeah, the video did once again get pretty long. So sorry for this one, but I guess this challenge is one of the most amazing challenges in this whole course over here. And therefore, I would like to put as many information into this as we have right now. Okay, maybe one last hint. If you patch some applications like this, I mean, you can also verify it afterwards, how it looks like. So we simply open this with JDX GUI. We go into the player input system. So it's within DE, Garbix systems, and then the player input system. Yes, and now if you scroll down, there we go. Okay, I mean, it's exactly like we have patched it. We use our position -15. The result of this will be once again reduced by -15. The result of this once again, and so on. We can also see this double shot CM has, the check is being in there, but the if statement has gone. So yeah, the result value V0 is holding the result value over of this one over here, but we are not going to use it in our code. So therefore the if condition has gone, and therefore we start with this player shot. And here's the other patch where we override our time to shoot with 0. All right. So thanks for being that patient with me and yeah, going through this whole solution. Now you definitely deserve your blue belt afterwards. Alrighty, so I hope this was funny also for you. For me it was a lot of fun, and I love playing around with these applications and patching it in this way. We have already figured out that the create player shot also contains a lot of more funny stuff. Feel free to play around with this one. And yeah, of course, if you have questions regarding to this one or regarding to other applications, then yeah, just drop me a message. I'm super happy to receive some feedback on this one. Alright, so this is all for the solution video right now. Sorry if it gets long once again, but it wasn't that long as the last one, so therefore we saved a little bit of time. And now I'm really looking forward to see you in the next video.